The next presentation, as I said, we are now going on to Cape Town, and it's from John Anderson from the UK, then moving down to South Africa, long distance. He was graduated from the University of Edinburgh, but quite quickly became responsible for very big building, construction, engineering structures and tasks all over the world. And so that's how he came to South Africa, and as I learned, he is now being a resident of South Africa. So he is responsible for a lot of major important bridges, and I think I don't name them now because they are coming now. But what I really would like to point out is that he really encouraged his colleagues not only to have the engineering structure in mind, but to be always aware that this is a piece of landscape, of like it's a piece of the public space we are creating. And the way he was describing his presentation from this very personal human aspect, that was what I think is really going to be impressive and makes me very curious about what is coming now, to get your very personal impression about your way of designing bridges and also the development you made. Thank you.
So this is not Cape Town, so I'll move quickly. Whoops. Okay, there we go. Good afternoon. I think it's afternoon now. It's a great pleasure to be here. I want to start, as other speakers have done, by just thanking Mike for the opportunity to be here and the opportunity to be one of the representatives of Africa. So I'm going to talk today about South Africa. I've lived there for 25 years, and I'm going to talk about my experience there, which I've just learned is overrated, Jörg, yeah, I think the main topic is going to be footbridge design. It's a great part of being a structural engineer is to get to design footbridges. And what's interesting about them is the creative opportunity you get when you get a commission to design a footbridge, and the fact that that structural design can become such an important part of the urban design, of attracting people, to and onto the structure, and then the fact that people get to interact with that structure at a very close scale. In South Africa, our pedestrians are not very ordered or disciplined. So there's a great need for footbridges in South Africa. And our biggest challenge is actually getting people to use them, not just to, not just to cross a grade. It is absolutely amazing what people will try and get across. So I'm going to start with the first footbridge I designed, which is back in 2007. And obviously all these bridges are designed by teams, in our office. But I think, I have to be very honest and say that, this is an amazing site. And the primary driver for me as a designer was to actually make the most of that opportunity from a design perspective and from a piece of urban infrastructure. And I was definitely influenced by some of the people in this room by going to footbridge conferences and seeing lots of beautiful white bridges made of steel. So, in the end, steel, I felt was the right material. I thought at that time that was the right material. It was light, you could create an elegant structure, and, actually, it's quite good in terms of the practicality of erecting a footbridge across the road. And we've had lots of opportunity in South Africa over the years. We had the World Cup in 2010, Soccer World Cup. There was a lot of bridges. And again, there was the opportunity to sort of service the functional need, i.e. getting these disorderly pedestrians up and over the bridge. That's what really drove the design of this bridge, was the functionality. We try and limit the grade separation as much as possible so that the deck walkway is as low as possible, so the height pedestrians have to climb is reduced. And we tend to use a lot of through girders, but in this instance, because we had multiple access and egress points on the bridge, we ended up with an asymmetrical structure with an upstand beam on one side only, and then this windscreen. If any of you know Cape Town, it's very windy, so we had this windscreen to, again, just encourage people up and onto the bridge. And in the end, I think a simple beam was the right answer, because when we started this project, many of our colleagues got very excited about cable stayed structures and arch structures. But in the end, when you're in a busy urban environment, a simple beam is sometimes the best. And then, the other aspects that you learn or experience as a structural engineer is, sometimes your job is just to sort of continue the ground, to create a perception that the ground just continues, and it sort of draws people across before they know it. And in those instances, it's really about collaboration with other professionals, with the urban designers, with the landscapers, and the structural design is not so important, but obviously it can have an impact, and it's nice to utilize that. This is South Africa, so everybody waits to the last minute. The gate's closed, and then they get trapped just before the bridge opens. So we had to put these turnstiles in at the end to sort of exit the disorderly pedestrians. But yeah, what's nice about it is many people use the bridge, and they don't actually realize it's a rotating bridge. So I have a colleague, his favorite question he likes to ask clients is, what keeps them up at night? What are the things they worry about? And, I think, as engineers, we've got to watch out for the trap of, we take the picture of the bridge, we put it in the brochure, we submit it to the awards, and then we forget about it. We've only known it for like 1-2 years, but it's got to survive out there for another 100 years. So what happens to it after 1 year, 5 years, 15 years? What is the reality? And sometimes it's not too pretty. This is a combination of dirt, grime, birds, skateboarders, you name it. And I think in countries like South Africa, the maintenance is just another burden on local authorities. It's sometimes not the priority. And, after 20 years, you get to see how the paint system works, and you get to see how your detailing affects the paint system. And you get to see the importance of tolerances in your design, be it construction tolerances or detailing tolerances. And this is just a simple detail where you can see the paint is failing at the stanchion where it drips down. So I think the lessons I've learned from observing, my own structures, other structures, is, sometimes painting the bridge white or light grey is not the best option. And that we should be spending a lot more time on robustness and resilience in our design. I think as engineers, I think that's got to be part of the design intent as structural engineers, that we do, include robustness and resilience in our design. And that we've got to be careful. We love, as engineers, a linear design process. We start at the beginning, we finish at the end. But sometimes if you get stuck with a technical issue and it's taking you away from the design intent, it's better to start again, but don't compromise the design intent. So I'm just going to show you some of the sort of bridges. This is a little through girder in the mountains in Cedarburg, and it's for school kids to get to school. Basically, they come from the rural areas, and cross this river. You might wonder what's going on with these stone piers underneath. So you can see the existing bridge was a timber bridge sitting on these stone piers that were built by the community. The contractor built the abutments, then he left site for a month, and the contractor thought, well, they forgot the main bridge. So the community started to build up the piers again to sort of reinstate the timber bridge to the abutments. So it was a big lesson on us to talk and to communicate with the communities how important it is. But this is basically just a variation on a through girder where we've just looked to reduce the material involved. We've taken material away where it's not needed. We've cranked the web just so that debris, as it flows down the river, is pushed under the bridge. And we've tried to keep people away from the webs as much as we can. And you know, we've got a very simple galvanized handrail, which is modularized, can be taken in and out, and a timber deck, which even the community can pick up, repair, and if you need to do maintenance to the steel structure, it's easy to pick up the deck and move it on. And we've generally, in our office, tried to sort of move towards, you know, if we are using steel, that it becomes a mechano kit that can be sort of easily transported and moved. Often we have these sort of rural pedestrian bridges where there's a sort of meandering river. The river moves, so it's good if you can disassemble the bridge and take it away. And you know, using very simple modular construction and materials. But even with that, you still have opportunity for having some aesthetic and urban impact. In South Africa, many of our sites, you know, the main requirement for the community is functionality. The bridge just must be functional, and it must be robust. And for our clients, obviously, we have to minimize the cost. And again, in these areas, the biggest issue is actually getting people to use the structures. So we still try and use through girders, but we've actually started moving away from precast and moving towards in situ bridges built on staging, so that we can create a concrete through girder that's a reasonable, friendly scale. You know, with precast, it's more difficult. And where that journey has taken us is actually, we found it's not so expensive. In fact, it's comparable, the cost of an in situ deck built on temporary staging compared to a precast girder. And there's a huge amount of opportunity in that fact. This is a stress ribbon that's sort of draped across a number of arches, and you know, the thrust from the arch is resisted or balanced by the tie in the stress ribbon, and you can end up with a structure that's wholly in compression in its serviceability state, and it's integral at its abutment, no joints, no expansion joints, no bearings. And it's actually, once the staging is in place, made safe, it's relatively straightforward. You build it like a cake, just in layers. And it employs people. In South Africa and Africa in general, labor is far less expensive than it is here. You know, this type of construction creates work opportunities. So there's a happy customer. But again, these handrails are very simple. You see they're not continuous, they're just modules, and they're placed there. So it's, again, relatively easy if you have to get in there and replace one. And we try and keep the sort of upstands as low as possible so that dirt doesn't collect on the decks, it just gets blown off. Our other big problem in South Africa is theft. We have a lot of theft of handrails. and even cables. So we try to sort of come up with ways of mitigating that. And we needed a suspension bridge here. There's some overhead power cables nearby. So in this instance, we've just used conventional cable-stayed monostrands inside a steel pipe that's then grouted up there afterwards. The anchorages are the steel assemblies at the top of the pylons, so we can get in there and inspect them. And again, it's a sort of self-anchored structure to reduce the size of the abutments. And we've been very judicious, robust in the design of the hangars. I think what you could say is, well, how do you replace that main cable? That's a fair question. The answer is you would have to prop the bridge to replace it, but the clearance is 5-6 meters, so you could do it. But it's a question, that comes up, I think, for many people designing suspension bridges. This is a bridge that Knight Architects and Arabs developed a concept. There's a very nice paper written by Angus Lowe about, how you can build in redundancy into a small suspension bridge. You can consider the event where one cable fails and the other cables carry the load. It's a very detailed paper. It goes into how you basically consider the dynamic effects and the tolerances in the remaining cable lengths. And the magic number is 4. If you want to not increase the overall cable quantities. So I would really recommend that paper if you get a chance to read it. And finally, I'm just going to talk about, we're lucky enough to be building a cable-stayed bridge on the Wild Coast in South Africa, beautiful venue, across a gorge, which is basically untouched. It's very difficult to get in and out of the gorge, and the vegetation there is incredible. And the client's going to be building a little footbridge across this side gorge to give a viewing point for the main bridge. And what was evident to the guys designing the bridge was, we obviously have to build it without impacting the gorge. But the question was also, how do you unbuild it if you want to regenerate the site? And I think in today's world, regeneration is important. Sustainability is not enough. We have to think about, how our structures play a part in a regenerative future. Can we take them apart? Can we disassemble them? This is the main bridge. It's a 580 span cable-stayed structure. The obvious response was a very slim, slender bridge. The big challenge for us was it had to be disabled access. It needed to enable disabled access. So the gradient of the bridge was a challenge using a catenary. And we've sort of tried to shorten the span a little bit. But the main idea that we had was actually to use timber. 3, I'm going to be finished in 2. So. The main idea was to use timber on the deck. And the reason for that was it's so easy to assemble and potentially disassemble. It can be bolted together, it can be spliced. And then we spent quite a bit of time just trying to see, well, can we use this timber in the structural design? And in the end, we've used it as a complementary part of the stress ribbon, so that under live load, the timber beams contribute as part of the stress ribbon, and it actually reduces the deflection of the deck quite significantly. So this is the bridge that doesn't keep me up at night. And I think for me, it just reinforced the importance of robustness and resilience and in designing structures, and how that actually changes your perspective on on design itself. But there's creative opportunity in it as well. It's just, another variable that we have to consider. But with that, it's just part of life's rich tapestry. We create something that's maybe a little bit different. And I think you can still, as designers, create something with a high urban design value, aesthetic value, by considering robustness and resilience. Thank you.
Do you have questions?
Having the office in Cape Town, how far is your reach into Africa from Cape Town further north?
So we operate in East Africa and South Africa mainly. We've given up in West Africa. So Kenya, Tanzania, Malawi, Rwanda, Botswana. So we do projects there, but very, very, very challenging business environment. I think, Africa, most governments are in debt distress. There's not a lot of money for capital projects, and the main projects tend to be IFI funded, internationally funded institutions. But there's a tremendous amount to do in Africa, that's for sure. I think the challenge is the investment, and and also the competitive environment doesn't lend itself to quality sometimes, and I think that's the challenge from a design perspective. You've got your work cut out for you in terms of changing that culture, yeah.
Hi. In your presentations, you mentioned multiple times about the requirements to reduce the effort on maintenance. Did you have to follow any guidelines in that regard, or did you have to design your own concepts that would actually lead to eventually reducing maintenance?
We tend to utilize resources from other countries as references. Specifically the Highways Agency in UK. South Africa in the past used British standards before it created its own. So there's still, typically the Eurocodes or the Highways Agency's references are used. But I think what you have here today is quite amazing, in terms of intellectual, experience and knowledge. In South Africa, it's harder to connect, and I think the mentorship that you have in Europe is far more substantive than we have in South Africa. So I do think what does end up often is that those references are not always known or accessible to within the industry, and it's definitely a task that to actually try and improve that within the South African industry.
Yeah, but my main point was it a requirement by the client to actually go towards reducing the effort on maintenance?
Some clients, yes. Like National Roads Agency, they would obviously, that would be one of their requirements. But local municipal clients, no, they rely on the professional or the consultant and the advice that they're given. Yeah.
Thank you.
Thanks.